Which negation will we take? Well, there is no anything in the text allowing me to decide between any kind of negations. And well, I will take the negation that is usual, that is 1 minus x. Of course, this means that the automorphism is 1, excuse me, it's identity. Then I will take not product C but product, and I will just work with minimum product. Of course, I have no any idea of which is the degree of life has sense attributed by the author. Even worse, it seems that this is open in the book. Then I will take this value as a variable value. You can say me, why you don't do the representation by algebraic terms, by Boolean terms? Of course we can. We can. This is this and this is true. Then from a Boolean point of view, this is true. Which is the problem? Well, the problem is that this material conditional does not distinguish between countersymmetrical conditions. And the author distinguishes. And then this is expressible by connectives. And by the other side, this model cannot take into account gradable statements. Then this is ideal, but it's not reasonable. Let me take this degree. Let me take this. This is a residuated implication. When t is equal to minimum, we have that. And this has only 2 values, and a discontinuity. No, it seems not reasonable. I take product, and then this is never 0, it's not linear, distinguishes countersymmetry. It seems enough complex for a worker which style is complex. So how we take this? With this, I can in an analogous way, I can modelize the degree if reading has error or life. I have this function. With these 2 functions, I can modelize the full statement, the full triple conditional, and I have this function. When is totally false? Only when R is 0. When is totally true? When R is bigger than this number that is very small. Because we say that T0 is very big, for example. If T0 is 0.9, R should be bigger than 0.1. As soon as R is bigger than 0.1, the statement is totally true. Okay? What happens with these values? The function rapidly decreases. And in a very small part of the square unit square, the function goes to 0 immediately. In the rest of the part, the function is practically 1. Then, gamma is 1 only for the values below this one. Fine. If this is 0, then conclusion. The reasoning is almost always true. Then, an adequate context modeling or design allow it to design a reasonably good representation of the given linguistic. Can we do that with different linguistic statements, larger phrases? Of course. We need to try. What with that? To have more expertise in the use of the fuzzy connectors. What more? To know when this armamentarium of fuzzy logic is not usable. It's not usable. Okay? It's not. You have syntactical advisors in the computer. They advise you. It lacks an age. This is not. I don't know. This phrase is different. The word is different. Huh? But we have no syntactical advisors. It would be a nice thing. A novelist is writing, pom, 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 and when he stops, for example, a large paragraph, if he stops, one, the syntactical advisor does what I did by hand, much more complicated, sure, much more complicated, but does something like that, and sends a message to the author saying, look, the last statement is almost always false. Not almost true, because if he says, as in this case, is true, the novelist just will continue. But if the advisor says, look, it's almost always false, what will do the novelist? He will stop. He will read another time this piece, and maybe he will rewrite. But it would be interesting to have this kind of. Okay, let me. While I talk you. I did nothing on Max Planck, and I think that is interesting. You know the Sorites paradox. Sorites paradox, for me, what says is that there are predicates that can collectivize in a classical sense. This is what Sorites says, with the grains of sand. This, the Bauman. There are predicates that it is not possible to represent them by a crisp set, because at the end there is a contradiction. Okay. Planck posed a very interesting question. Is there a separation point? That means, in the universal discourse, is there a point up to which I can say that all these objects are P? But when passing this point, I cannot say that these objects are P. Look, I have a heap of grains. Which number of grains allows me to say this is a heap? Which number? Or I am young. A person is young. Up to which number of years I can say that this person is young? Planck said that the idea is good, but it is impossible to find this volume. It is not impossible. It is not impossible. Look, a very curious situation. On Sorites, there are a lot, I don't know, thousands of papers by philosophers. No one of them describes what is for he or she a head. How is it possible to talk on a head without describing what you understand by a head? I think that a scientist will do never this. If I'm using a word, I will know how to use the word. It's possible to talk on prime numbers without defining what a prime number is. It's possible to write 1,000 papers on prime numbers without knowing what a prime number is. Well, there are hundreds of papers on Sorites without describing what is a head. Well, I think that this is curious. What I am trying is not to explain the paradox, because I think that there is no paradox. What is a theorem showing that some predicates can have classical extension, nothing else. I will try to dissolve the paradox. Well, imagine that the fuzzy set, they take a closed interval of the real line, because in all the examples in philosophy, they use number of grains, of number of hairs, numbers, and I just take that. Okay, all the cases on Sorites, the function is increasing or decreasing. Okay, when the function is not decreasing, this number is the separation point. Why? The points here are those in which x is less p than not p. As soon as I will pass this number n, the object will be more not p than p. This seems clear, I can stop. For example, imagine that I take the predicate young. Okay? And the predicate young is represented by this fuzzy set in 0, 10. Okay. Imagine that I realize, by the use of the language, that the negation should be represented by this Sugeno negation. Okay? I make this inequality. I solve this inequality, and I have this solution. 41.42. In the hypothesis that young is represented in that way, and that the not is represented by this negation, I say up to 41.42 is young. But in the moment in which I will pass 41.42, it's not proper that to say that is young. That is more not young.